And I'll remember to click this button. Question?
What's the initial password again?
Same as your username.
Okay.
Yeah. I can reset it for you if you're having issues. We'll do that. We'll do that later, though. Any other questions before we get started? We're all remembering how to log in. All right, so yeah, get that in, please, and then we will do our first programming lecture. I'm so excited. If I'm the first person to teach you programming, I am honored. So we are going to be going to a couple places today, a couple websites, and these are the links right here, and we'll go back to them in just a second. But definitely, because this is an online website where you can program stuff with, it's called Scratch. Please follow along if you can, and I'll help you come around, make it all work. Ask lots of questions. If there's something that I do that you didn't quite catch, just tell me to do it again. There's plenty of time for that today. I want to make sure we can all follow it. Okay, so let's do it. Let us learn a little bit of programming. All right, the very first thing that I want to talk about is just programming in general, not a particular language, just the idea of it, because it's a new kind of idea if we've never programmed before. So what in the world is a program? What in the world is an algorithm? I would say that a program is a combination of a bunch of little algorithms. So what's that word? An algorithm is just a sequence of steps. It's really just a recipe to make something virtual, I guess. But really, yeah, an algorithm is technically a recipe. Yes? Okay, I'll come help you later then. Algorithm is a sequence of steps that achieve some goal. So if you're making food, your recipe is an algorithm. If, I don't know, your work gives you some sequence of steps to do to produce some report, that is an algorithm that you are following, right? So a program is just a recipe. So let's pretend that I have amnesia and I really feel like a peanut butter and jelly sandwich, but I've forgotten how to make one. So can somebody please tell me the algorithm to make a peanut butter and jelly sandwich? What is it? Yeah, exactly. So that is a valid algorithm. Perfect. That's a recipe. I think the standard answer would be just take some bread, put some peanut butter on it, put some jelly on it, right? That's peanut butter and jelly, right? So exactly, that's the age-old question. So if I was a computer, though, let's pretend that is our program. Let me pretend to be a computer running that program, okay? So you're like, all right, to make peanut butter and jelly, just take some bread, get some peanut butter, put it on the bread, get some jelly, put it on the bread. So as a computer, me running your program, I would get a bag of bread. This is my best drawing of a bag of bread. And it's got little slices of bread inside of it. So that's bread. And then, all right, I'm a computer. I'm running your code. I just got the bread, and now I'm going to put peanut butter on the bread. So I'm going to take the jar of peanut butter. I'm going to put it on top of the bag of bread. And you said jelly, too, right, on the bread. So let's take the jelly jar. Poop. Put that on the bread, too. And voila, I just ran your program. That's peanut butter and jelly. That's exactly what you wanted, right? Shiny and new. That isn't what we wanted, was it? So, yeah, the main moral of this story now is that as a computer, if you give instructions to a computer, it's going to follow them specifically. The computer is very, very fast at doing things, but it can only handle so much at a certain time. It only knows how to do certain kinds of instructions. You have to talk down to it in a sense. So the proper algorithm, the proper way to specify how to make a peanut butter and jelly sandwich to a computer would probably be something at a lower level. Like, okay, computer, take the bag of bread, open it up, get 2 slices out of the bag of bread, put them some way face down on a plate, get a knife, put the knife in your right hand, open the peanut butter jar with your left hand, dip the knife into the peanut butter jar, spread it on one side of the pieces of bread. That kind of level. That's how you need to talk to the computer. Does that make sense? That's the main difference. You have to talk to a computer in the way that it knows how to understand, and there will be no ambiguity at that lower level. Okay, so you got to use small steps, be super specific. That is computational thinking. That's thinking like a computer. Okay, so that is probably the goal of all of my programming lectures, teaching you to think computationally, to make your own little recipes that make some virtual thing on the inside of your programming language. Are there any questions about that idea? Probably the most important one. All right, so I'm going to teach you a language today called Scratch. And let me show you what's going to happen. So it's a graphical programming language. If you've never seen it before, you're going to be dragging things onto the screen and they will become your program. It's like you're building a program with Legos. So you're going to be dragging these things called blocks out onto the screen, and they all do different things. Like here's the first block. You can drag it out as a little cutout because it's like a puzzle piece or a Lego brick. And it does some operation. It like adds numbers, prints stuff to the screen. So here's operation 1. And then you can drag another block below it, and it all links up. And that'll be like operation 2. And you can drag a third block, operation 3, and they all fit just so nicely together, and they all do stuff. Okay, so 3 operations, one after the other. And the way this program will run when you start it is it'll first do this block, then this block, then this block, in order. Okay, it's going to do those 3 operations in order from top to bottom. Okay, and so they're going to what's called execute in order. Execute is just a fancy word for run. You're not like killing a program or anything. It's another word for that. Execute in order or run in order. Okay. So that's the kind of programming language that we're going to make, and it's called Scratch, and it lives at a website called scratch.mit.edu. So let us all go there. Scratch.mit.edu. This website up there. And once you get there, you'll click Start Creating. Scratch.mit.edu, start creating, and it will plop you into a page that should look like this once it decides to load for my computer. It's trying super hard. It's getting there. You can do it. Oh shoot, I might have to restart my browser. It's never been this slow before for me. Try again. That's better. So it takes you to the page that looks like this. And by default, in every Scratch program, you get what is called the Scratch Cat. That is you can get rid of the Scratch Cat, but we like to keep them around. There's actually a whole Wikipedia page about the Scratch Cat, very famous. There's like lore written about this nice virtual being. And so, yeah, Scratch Cat is the default sprite. So much information about the Scratch Cat, if you'd like to look into it. But this is like your blank screen. And so here are all the little blocks. Can I zoom in anymore? I think, no, I gotta be like this, sorry. Yeah, that's as good as it's going to get. Here are your little blocks. You can drag them over to here. So like on the left-hand side, you have the things that you could use to make a program. In the middle is where you put the program that you are building. And then on the right is where your program runs. You're going to manipulate this little screen that maybe makes the Scratch Cat run around and do cool stuff and interact with other things. The Scratch Cat is called a sprite, by the way. An interactive object called a sprite. Okay. So, let's see, what do I want to do first? Yeah, I think, let me just show you a few of these little blocks and how the sprites are arranged. So down here, if you click on the Scratch Cat, you can of course drag him around. And notice, I'm sorry it's so small, I can't really zoom in very well, but notice that there's X and Y coordinates down here. Can you see my mouse moving? There's those X and Y coordinates and they change. So the Scratch Cat's moving around in the world, and the X and Y coordinates are changing. You will eventually be able to programmatically change those X and Y coordinates to make an animation happen. Okay. There's also a concept of a size. You can make the Scratch Cat 200% his size. Giant Scratch Cat. You can hide and show him. By default, he's shown. You could hide him. Hide and show. You can give him a new name. Sprite 1's a silly name. Let's call him Scratch Cat. And now his name is Scratch Cat. Then there's also a concept of direction. Right now he is looking to the right, and so he's facing 90 degrees, let's say. That's that. And you can spin him around, get him started in whatever position you want him to be. Okay? We can go back to 90 though. So that's how you interact with your little sprites and you get things started, but that's not yet a program, of course. That's just all these little things, eventually you can interact with them using blocks. You can change them using blocks. Make the scratch cat giant for a little bit and then make him normal size. Okay, so are there any questions about this idea, these block ideas? Because this is going to make our program. Probably the simplest block, let me just show you how they work. You drag them out here to make your program, like move 10 steps in your current direction. And to run this block, if I want to run it, I can click on it. Click. And the scratch cat moved. He added 10 to his X position. That's how it worked. 19, 29, 39, 49. And maybe we want him to walk way over here. So that's a program. And you can change this, move 20 steps instead, please. All that stuff. Okay? Move 20 steps. Turn right 15 degrees. That's another block. I'll put them separately right now. So I can move 20 steps, turn 15 degrees, move 20 steps, turn 15 degrees. If you would like, you can make a bigger program. You attach them. Yeah? Just like I was saying. So it'll do the first block and then the second block in order. It'll run that code. So move 20 steps and then turn 15 degrees all at once. Boop, boop, boop. And I was like walking around in a weird looking circle. Clicking it. So this is just 2 blocks. I think you can imagine how cool you could make your programs if you had more. If you dragged more out into the screen, out into your program. Okay. So yeah, there's a lot of different ones, like go to random position, glide 1 second to a random position, take 1 second to get to that random spot that you just chose for yourself. And you can of course combine. Glide 1 second to a random position, then move 20 steps wherever you ended up, then turn 15 degrees to the right. All those 3 things in order. So yeah, very complicated programs. And this is just the motion section of all the code. You can move down and do other things. There's a million things to play with, and we'll all get there in due time. Okay. So are there any questions about just the general idea of programming with this language before I show you some well thought out examples? Ready? All right. So I would be doing you a disservice if I did not show you this program first. It's called Hello World. When you learn a programming language for the first time, it is customary to make your first program, your first real program, be one that just prints to the screen the words Hello World like your program is sentient. You have given it life. So let's do that. Okay? Let us figure out how to do Hello World in our program. Find the block that prints to the screen, Hello World. So if I don't want these blocks anymore, I can just drag them back. They go away. I zoomed in, by the way. That's why it looks so big to me. But let's scroll down and see if we can find a block that looks like it might eventually say Hello World. I think I found it. It's down here in the purple section, the looks section. You can either say hello, and you can of course change this, or you can say hello for 2 seconds. I like the idea of saying something for a given period of time. So we can say hello world, comma, space world, exclamation point, for 2 seconds. And if I click it, it will run. And the scratch cat says hello world for 2 seconds, and then the speech bubble disappears. Okay, so that's like our first real program. Does that make sense? Not too bad. And if you want him to say more things after that, you can have another say block, put it below, say something different. Hello world, then hello. Why not? Whatever you feel like. And you can change the amount of time that he's talking for. I'll drag this back to delete it. But that's a simple program. And one thing I do want to say first, though, is every program is associated with the sprite. So I only have one sprite right now. This is the default scratch cat down here. He is selected. This is his program. So he's the one talking. That's why it's working like that. If there are other sprites on the page, and I'll show you more later, then they all get their own program to run. They could all run a different program at the same time, in fact. Okay, so that's Hello World. Yeah, let's make this more correct, because right now you're just clicking blocks and they run. That's really not the right way to do it. Okay, you want to start the program in a different way. So let me show you how to do that. That's called an event. So in Scratch, normally we start our program with something called an event. Okay, and yeah, so clicking on a block to run it, that's like good for testing, but it's not really running the program in the right way. So the standard way of starting a Scratch program is to click this little green flag. So we want to hook up this block to run when the green flag gets clicked. That's the idea. And so that's way down here in events. And notice how these are blocks that start programs. Notice how nothing could hook into the top of them. That makes sense. There are a bunch of different events, like if you press the space key, the program below will start. If you click the sprite, the program below this one will start. But if I hook this one up, just like that, when the green flag is clicked, it will start whatever is underneath it. It will run whatever code is underneath it. So now, this is a more correct Hello World program. If I click the green flag, it's going to fire this green flag clicked event and start running everything below. Hello World. Another nice thing about this is if like your program goes haywire, you can just click the stop button. And it'll stop everything that was started when you click the green flag. Okay. So that is Hello World in a nutshell. And I'll give you this code, so I'll save it to my computer. And I'll make new code and save that too, and give that to you too. Okay, so that is an event. Events can't have blocks above them because they start the computation. And then the last thing I want to show you is a comment. Let's say you made this program, it made sense to you when you made it, but you're going to go on vacation for a week and you might forget. So if you right-click on any block, you can say add comment. And that leaves a little sticky note for you to leave a note for yourself. It's not part of the code. It's just for you, the programmer, or for anybody who sees your code. Okay, you can say this is a comment. It's just for the programmer. You can write whatever you want in here. Okay. Actually, I kind of want to save that one, not a different one. So let me delete this one, this downloaded thing, and let me save this version. So that's a comment. You can leave as many as you want. You can leave a comment on this one. Be like, all right, what does this line do? It prints hello world. In case you forgot, for 2 seconds. So that's my program. You can leave comments for yourself. That's a very common thing to want to do. All right. So yeah, questions about events, blocks, comments, anything like that? All right. Let me make a bigger example then. I'll go to File, New. Do I want to get rid of everything? Yes, I do. So let's get started. Let me show you a new concept. All right, so let me show you an example of animation. Let's make a program where the Scratch Cat gets something out of the fridge. Let's say the Scratch Cat's hungry, it's the middle of the night. He's going to get a banana out of the fridge, and let's set this up, okay? So I need to set the scene, of course. So we have the Scratch Cat. Give him a real name, Scratch Cat. Let us introduce a backdrop with a fridge in it. I think it's just called refrigerator. There it is, refrigerator. So now there's a nice little backdrop there. We got the Scratch Cat. And we also need some bananas to interact with. That's another sprite. So I can click choose a sprite, find bananas. There they are. And they also appear on the screen. Okay? So I can put them in the fridge. And then here's the Scratch Cat ready to go and get them. Okay, so that's the setup. Oh, it was down here over here in backdrops. It's the other button on the right. Yeah. So is everybody able to get this who wanted to get this? And now we have to talk about how to make this program, because we want the Scratch Cat to programmatically walk over here to the bananas, get them, and then maybe walk away with them. That sounds like a good program to me. So we need to come up with an algorithm to do this, don't we? So here's my silly little algorithm, and here's how I'll do it. We have to do some kind of thing called initialization, and I'll show you that in a second. The bananas need to start out in the fridge because we need to go and get to them. And then the Scratch Cat needs to start out to the right of the fridge. Okay? And then we need to have the Scratch Cat walk a little while to the fridge to go and get the bananas. Can you guys not talk while I'm talking, please? Thank you. So we're going to have the Scratch Cat walk to the fridge, get the bananas, and then walk away. That's the idea. And we're going to have some concept of waiting, because we don't want the bananas to start moving until the scratch cat is over to them. That's important. So let's try and make this happen. So I am on the scratch cat right now. He gets his own program when the green flag gets clicked. Notice I can click on the bananas right now, and everything just went away. And there's a different picture up here on the right. This is the bananas program now. It's a different program. It can do different things when the green flag gets clicked at the same time. Woohoo. So the very first thing that I want to have happen is for the scratch cat to walk over and get those bananas. Okay, so start over here, and he needs to walk over to wherever this is, right? Notice that there is a very nice thing happening over here in the code on the left. If I move around the scratch cat, do you see how some of those coordinates are changing? That's very convenient for us, the programmer. If I want the scratch cat to end up right here, that's apparently -166, -98, I can just now drag the block out. It's set to that particular coordinate. That's beautiful. So if we put him back over here, it saved that. So take 2 seconds, Mr. Scratch Cat, to glide to that location where I put you. And so now if I click the green flag, Scratch Cat's going to glide over to the bananas, and then eventually he's going to walk away with them. What will happen if I click the green flag again right now? What do we think? Is there a problem? Well, I can just do it. Whee! 2 seconds to do nothing. What happened? What was the problem? He was already exactly where he needed to be, so he took 2 seconds to go nowhere because he was already there. So at the start of the program, we kind of need the scratch cat to be right there on the right side of the screen, don't we? And that is called initialization. We need to initialize the scratch cat to be at this position first, way over here. Does that make sense? So just teleport right there when the green flag gets clicked if you're somewhere else, because then you'll be in the right spot to move over and actually have somewhere to go. So now if I click the green flag again, because of this first line, because of this first block, he's going to teleport right here when the program begins. Okay? That's important. Boop. Then he takes 2 seconds to get over to the bananas. That's exactly what we want. Okay? And then we want him to walk away with the bananas too. So he needs to like glide back after he's over there and he's got them in his hand. So glide back, take another 2 seconds to get to that spot. Okay? So that's like the Scratch Cat's program. That's all we really need for him. Got to walk over, get the bananas, and walk back. And this is a program affecting the Scratch Cat. We're moving him. Go here, glide here. Talking about the Scratch Cat. We would like to now do stuff with the bananas, so they need their own little program, right? Bananas. When the green flag gets clicked, what should the bananas do? So they need to kind of move with the Scratch Cat way over here. Right? They need to go to that position. They need to take 2 seconds to get there, don't they? So maybe they can do that when the green flag gets clicked, if they're over here to begin with. So remember what the Scratch Cat's doing. He's teleporting here, gliding over, gliding back. Here's what the bananas do when the green flag gets clicked. Glide 2 seconds over there. What's going to happen if I click the green flag now? Will it work? Sorry, I can't show you both programs at the same time. Whee! So they passed each other. What? What was the problem? The Scratch Cat took 2 seconds. This teleportation at the beginning is immediate, but the Scratch Cat took 2 seconds to get to the fridge. The banana shouldn't move until the Scratch Cat's there. So the bananas need to wait 2 seconds, don't they? Before they move. That's important. So the bananas need to wait 2 seconds to start moving because only then will the Scratch Cat be at them and ready to move away. Okay? So there's a wait somewhere. Gosh, where is it though? Is it in events? It's in control. Wait 2 seconds, please, bananas. And then you can walk away with the Scratch Cat. So wait 2 seconds for the Scratch Cat to get there. I can leave a comment to hit. Make sure you remember this when you look at this code when I give it to you. So the bananas need to wait for the Scratch Cat to get to them, right? They need to wait those 2 seconds because that's how long it takes for the Scratch Cat to glide over to them. taking 2 seconds. All right. Boop. Whee! Beautiful. All right, is this correct? Am I done? What happens if I click the green flag right now? Will it be a correct program yet? I see some no's. Why not?
You gotta reset the banana starting.
Very good. Yeah, so right now the bananas have no initialization. That's the fancy word. They are right here unless I tell them to go somewhere else at the beginning. They're stuck there. They're gliding 2 seconds to nowhere. So if I want the bananas to start in the fridge when the program begins, I better put them there, right? Teleport, please, right there as the program starts. And now I think we've got a program. Boop, boop, walk away. If I click it again to restart the program, everybody initializes themselves. The bananas wait 2 seconds, and then they start gliding to the scratch cat, or with the scratch cat. And we have a nice happy ending to our story. Any questions about this? That's our first real life program that does something non-trivial. We have 2 things happening when we click the green flag, affecting the scratch cat sprite and the banana sprite. And they're all kind of working together. We good with that? Maybe we want to study it? So I'll save that and give it to you too. That's my next program. All right. So let's see, what else do I have for us? I'm going to show you, I have one last cool example, and then I'll let you try it, and then I'll help everybody who's having trouble logging in on the class website. Let us do my final example, if there are no more questions. Right? We're all right to move on to the last most complicated example? All right, here's my silly idea. Let's make an alien abduction animation. So the scratch cat is going to get abducted, and he's going to fly into a saucer and disappear, and the saucer will fly away. So we're going to care about initialization all over again, but here's the exact definition. It's like something is initialized when you give it a starting value. So we initialize those bananas. And so here's what I want to do. Here's my algorithm for this alien abduction animation program. So first of all, we need a cornfield or something. That's just the standard backdrop, right? So is there a farm? I think there's something. Hayfield, yeah, exactly. So here's the scratch cat just minding his own business. And so we need him. We can give him a name. I like calling him scratch cat. Doesn't really matter though. And I think there's an alien saucer spaceship or something like that. We can use a rocket ship. Pretend that the aliens are in the rocket ship. And then there needs to be some sort of beam that comes down to snatch up the scratch cat. And so we can actually draw that. We can make our own sprites. So instead of choose a sprite, you can go up here to paint, and then you can make your own little thing over here. It opens up a little editor, and I think I can just do something like this. Boop, 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 boop. And I can fill it with some sort of, is it allowed to be transparent? Can't remember. Something like that. Now, color, saturation, brightness. I don't think there's transparency. What about you? No fill. Oh well. There's a way to do it. Let me show it to you. This will be I forget, a tractor beam? What's the word for this? Let's say beam. We want it to come out of the rocket ship and take up the scratch cat. So if you want something to be transparent, you can actually do it in looks, I think. There's an effect for that. It's change, not color effect, but ghost effect by, I don't know, 50%. Whee! So that looks like a tractor beam now. It's transparent. So as long as you start it like that, I think it's fine. Just stay like that, please. So yeah, those are the 3 pieces that I need now. And now we can make a program out of it. Boop. So I would like the scratch cat to be minding his own business. And then the UFO should appear out of nowhere. So I should start out the beam and the rocket ship as hidden. like that. And then they will eventually come into frame. They'll show themselves. You have these down here in looks for that. You have the show block and the hide block. We'll need those. Show, hide. Show the rocket ship, hide the rocket ship. Show the rocket ship, hide the rocket ship. Yeah. So we'll need those in a second. We'll bring in the event as well. And then we want the rocket ship to like gently go down here, bring out the tractor beam, have it appear, and then pick up the scratch cat, like the scratch cat starts moving up into the rocket ship. And then they all disappear, like the beam goes away because you got the scratch cat goes away, and then the rocket ship flies away. That's kind of how I want to do it. Does that make sense? Seems kind of logical. So UFO moves closer to the ground, sends out a beam. The cat glides upwards into the rocket ship. And then the beam and the cat go away because the cat is now in the rocket ship, and then the UFO flies away. So all of those things interacting together, initialize properly, etc. That's my goal. Okay? Any questions about what I want to do before we do it? All right, so I guess at the very beginning of the program, I would like all these things hidden. The rocket ship hidden, the beam hidden. The scratch cat can stay right here. And I want the scratch cat to start right there. Like let's do that initialization. Like no matter where he ends up, at the very beginning of the program, he should be right here standing in the field. So go there. And then when the green flag gets clicked for the rocket ship, it should appear. It should show itself because it's hidden. Then, after it's shown itself, it can maybe like appear right here at the very beginning. Okay, so maybe show yourself, go here before you're shown, and then show yourself. So you appear right here, and then glide down a little bit to get to the scratch cat. Glide 1 second, not to a random position, but 1 second to there. Then send out the beam. That's a different program. We'll worry about that later. Then the scratch cat needs to go into the beam, and the rocket ship needs to fly away. It needs to like glide upwards and then hide itself. Glide upwards, hide yourself. That's kind of like the rocket ship's program. Start here, move down a little bit, wait for the scratch cat to get into the rocket ship, then fly away, hide yourself. Whee! So this is me running the rocket ship's program. Kind of makes sense. Coming in, moving away, disappearing. Coming in, moving away, disappearing. Any questions on why these blocks do those things? Kind of self-explanatory, but it's just a lot of things in order. I can understand that it takes a while to wrap your mind around this kind of computational thought. But that's like the first part. So the rocket ship comes down, and it took 1 second to get where we needed it to be, right? After that 1 second is when the beam should appear. Does that make sense? Because the rocket ship needs to move down, then we'll let out the beam right here in between these two, this block and these blocks. Right in here. So how long should the beam wait before showing itself? If we want the rocket ship to move into position, right there, how long should the beam be waiting before it appears? It should not appear immediately because the rocket ship isn't ready for it yet. It needs to move down, then it can appear. How long does it take to run these 3 blocks? This one takes a second. Anything that doesn't have any time associated with it is immediate. So you can assume that these 3 blocks run in 1 second. So that's how long the beam should wait before it shows itself. Does that make sense? That's how you do it. So events, when the green flag gets clicked, the beam should wait 1 second, that's in control, before it shows itself. Looks. And this is how long it takes. It takes 1 second for the rocket ship to move into position. course, rocket ship is 2 words. Okay? So, yeah, it should start out hidden as well. Whee! Comes down, and then something like that. I guess we should always make sure that it is transparent. I would prefer that. So that is in looks as well. Let's change the ghost effect. Let's make it like 50% transparent. Always. Yay. And so now we need to do the rest of the stuff. So the tractor beam is down where it needs to be. Maybe the rocket ship needs to move a bit closer to it. We'll deal with that in just a second, I guess. So, right. Where's a good spot for the beam to appear? It needs to be up a bit higher. How about that? That looks a bit better. Okay. And then once the beam is in place, we need to have the Scratch Cat move up into the rocket ship, right? So now we have to think about how long did it take for the rocket ship to move down, for the beam to appear? When should the Scratch Cat start gliding up? Yeah, we gotta time this. So again, when does the beam appear? The rocket ship moves down, and then the beam appears after 1 second. So that's when the Scratch Cat should start moving, after 1 second. Because that's when the beam has shown itself. Yes? You see how I'm reading that, how I'm thinking about that? So the Scratch Cat should wait 1 second, because that's how long it takes for the beam to appear and the rocket ship to move down. Beam/rocket ship to appear. Get into position, let's say. And then the Scratch Cat can start gliding upwards into the rocket ship. So maybe we'll put him right there. So take a second to get to that spot, please, Mr. Scratch Cat. So this is looking more like a program. Boop, boop. He's moving up. The rocket ship right now, though, is moving down immediately and moving away immediately. I think we should put something in the middle here so that the rocket ship is in place in the same spot while the Scratch Cat's being beamed up. So I think we should wait right here in between the rocket ship moving down and the rocket ship blasting off. Yes? That's the kind of stuff you got to think about. So I'll put another wait 1 second in there. Add a comment. Let the Scratch Cat get beamed up before disappearing, before flying off. And again, this is the rocket ships program that I'm working on right now. Please wait. That's looking better. That's looking much better. Are there any questions about it right now? Have we all been able to follow this? Good, good, good. Yeah, please shout out if anything is not making sense, because we're almost there. The last piece of the puzzle is, all right, the Scratch Cat has been beamed up. The rocket ship is ready to blast off right here. That's the line that's going to blast off the rocket ship. How long did it take for the Scratch Cat to get beamed up? You had to wait 1 second for the rocket ship to appear, and then 1 second to get beamed up. So after 2 seconds, the Scratch Cat is in the ship, right? So at that point, we should hide him, right? He's already in there. We're good to go. So let's hide the Scratch Cat after he's done being beamed up, after this block is finished. Hide, okay? And then also, after the Scratch Cat took his 1 second to get beamed up, we should also hide the beam, right? We can't do this. We can't say show hide, because this will immediately, take place immediately. It's show. Wait a second for the Scratch Cat to get beamed up. Then we can hide the beam as we hide the Scratch Cat. So there's 3 different programs playing with each other right now. A lot of waiting in each of them. That's important. So this is 1 second for the rocket ship to move into position. And this is 1 second to keep showing the beam, right? Because it's show in between a hide. Keep showing the beam for that 1 second. That's how long it takes for the Scratch Cat to get beamed up. Then we're done with the beam and the scratch cat. Boop. That goes away. I think that's good enough for me. But we're not quite done yet, because if I rerun this program, the scratch cat never appears. Because we hit him at the very end once he went into the spaceship. So if we want him to be there at the beginning of the program, we better show him. We better initialize his position as well as his visibility. Please show yourself. Boop. And that looks more like a program to me. So these are all playing with each other. All these three sprites. Let me see if I can read this to you. So at the beginning, the scratch cat initializes himself to be in the middle of the field. Go here, show yourself. Wait a second for the animation of the rocket ship to move down, right? Then the beam has appeared, glide into the beam, into the rocket ship, and then you're supposed to be in there, so hide yourself. That's the scratch cat's program. Rocket ship's program. Initialize yourself to be at the top of the screen. Show yourself, because you're going to hide yourself eventually. Glide down so you can get next to the scratch cat. Wait a second, because you have then shown the beam in other programs, and then wait for the scratch cat to glide into the rocket ship. And then, at that point, the scratch cat and the beam should hide themselves, and the rocket ship, because this is its program right now, will glide away off into the distance and hide itself. Finally, the beam. Start out hidden, just like the rocket ship. Make sure it's transparent. Wait a second for the rocket ship to move down. Show yourself so that the scratch cat can be beamed into you, and there's a beam visible. It takes 1 second for the scratch cat to move upwards, so stay shown for that long. And then the scratch cat is inside the ship. We can hide the beam, and we don't have to worry about it. Notice that I never moved the beam, so the position never needed to change. I never needed to initialize a position, just the show hide thing. So that's all three programs working together. That made enough sense when I talked about them. Any questions about this? Are we all able to get it working? All right, so here's what I'll do. I'm going to save this, and I think the best place I can give it to you right now is Discord. So that's where I'll give it to you. If you'd like to log in on Discord on your own laptop or on the web view in whatever browser you're using on the school computer. But I'll give this to you if you would like to use it, and then I have a challenge for you. Okay? Once this decides to start up, of course. This is a very slow laptop, and Discord is, it's got 15 more updates today. Let me talk about what I want you to do while it's starting itself. How about that? Here's my challenge for you, and I'd like you to help each other, help your neighbors as you're working on it. I'll give you plenty of time. It'll take like 10 minutes to do this. I want you to recreate this example. You can start with the code I give you if you'd like, but I'd like you to change it. You should let the scratch cat get away safely this time. You can have him yell at the rocket ship, something like that, run away. But you know all the steps now to do things in order and change up the animation. So that's what I want you to do. Okay? Feel free to play around with anything else if you'd like, but I'm going to give you this program, and I'll give you 10 minutes to try it. And then I'll come around and help people, answer questions, and deal with class website issues as well. So I'll put this on our CSCI 1 channel if you would like it. It should be the latest one that I saved. There you go. Scratch Project 2. You apparently have it now, so okay. I'll give you like 10 minutes to work on this, and please ask me questions as you do. This is my challenge for you. And then I'll talk to you about your first programming assignment after that. And then that'll be all I have for us. All right. Who was having trouble with the class website? So I can help you with that now. Oh, cool. Nice. Anybody else having any issues with anything? Otherwise, I'll just walk around and see your cool programs. as well. If you're gonna have like the scratch cat jump up and punch the rocket chair. And so actually, we all marked ourselves here today, right? We're all done with that in that case. So I will end this and nobody will be mad. Speak now. I'll give you another minute to try. Make it work. Oh yeah, question. How do you set the rotation?
We reset it.
It is 90, so it's always this point direction. Set the direction to exactly this. 5 more minutes. At least that's what my timer says. So everybody has logged in and done attendance now, yes? Speak now. I'm about to end it. All right. So now you can confirm you were here if you were scared about that. All right, got 2 more minutes to make a beautiful work of art. All right, that's my timer. Hopefully you made something beautiful. Feel free to keep working on it. We have plenty of time left, but the last thing that I want to do officially today is talk about your first programming assignment. So I hope you enjoyed this. If you've never programmed before and this was your first time, hopefully this wasn't too bad. This is going to be the language that we use for the first few weeks of this class, first maybe half of the class. So here's what I want you to do. I'll release programming assignment 0 now. So it should be visible on our canvas. And this is going to be due next week. Not on a class day, so you're welcome for that. I'll have it be due on the 18th, so Thursday. Okay? So you can ask me about stuff in class all next week or in office hours. So this will be due on the 18th. And here is your instructions. So I have, remember, if you've taken a computer science class or you know how to program already, I have a different assignment for you. So I'm going to first talk about the assignment for students who have not programmed before. Okay? So you're going to pick the one that applies to you. So for you, if you have never programmed before, then I would like you to do this activity. You're going to go to hourofcode.com, and they have Scratch-like languages there where you will just pick one of these activities, and you can make Flappy Bird. You can do so many cool things, and it's going to have a little tutorial for you to go through and a nice, pretty, usually a game that you end up with. So pick the one that looks the nicest to you and do it, and just send me a screenshot or post a screenshot as proof that you did it. So yeah, pick whichever one looks fun, and for credit, you're going to be turning in a file. Please just take a screenshot that shows that you completed the activity. Some of them give you like little certificates of completion. You can take a screenshot of that, or some of them are just like, you're at the end of the lesson, you're done, check mark. You can give me a screenshot of that. Whatever you need to show me, and that'll be how you get your credits. So you're going to go to this website, pick a fun activity, and code it up. Okay? And it'll teach you how to do it along the way. It's very similar to Scratch, and if not exactly the same, depending on the one you pick. And so that's you if you've never programmed before. Are there any questions about that? Just go there, do the thing, take a screenshot. If you have programmed before and you don't want to talk to me about getting something custom for you, because I'm definitely willing to do that. If you have something that you're interested in, we can come up with a set of assignments for you to replace this one. as long as it's of similar difficulty. But if you have programmed before, I would like you to learn a fancy language that's going to look weird to you called Racket. And so I want you to read these two sections of this textbook called How to Design Programs. You click on it. It's in the first section. So the first two sections right here, just arithmetic, 1.1 and 1.2. Where was I? Oh, I was here, sorry. Read those, and it'll teach you this language called Racket, which is made up of a bunch of parentheses, which just looks really weird. And so it's going to bend your mind a little bit, and that's what I want. So read those, and you're going to install the Dr. Racket language and install that and do exercise number 2 from probably the second chapter. So do this exercise and then just like send me, post a screenshot that you got the right answer. Okay. So that's what you'll do. Upload a screenshot as proof. And yeah, contact me if you'd like to do something custom instead of similar difficulty. So those are the 2 assignments. They'll be due next Thursday, whichever one applies to you. Are there any questions about that? Hopefully that's straightforward enough. But yeah, that is officially all that I have for us today. So you're free to stay and keep working and ask me questions. But if you would like to do your assignment in privacy, you're free to go.